So I'm going to improvise this presentation a bit. Usually I'd have some more details, but basically if we like this is a very interesting event. Thank you very much for giving me this opportunity. And Yield Systems, we are a company that focuses on agricultural data production. So my background is in developing machine learning methods for plant breeding during my PhD studies. And at that time, we very quickly realized that the bottleneck for modern predictive methods is not the algorithmic capability, but instead the quantity and quality of input data. So algorithms can do excellent predictions when they are given with good input data. At that time, there were already quite many drone-based, I actually have a slide for this. So there were actually quite many drone-based solutions on the market already. But the challenge with the drones is that they can only see the top 10 centimeters of the canopy, whereas agronomists often are interested in information from the full height of the plants. So we wanted to develop something to address this need. And what we came up with was this extremely simple solution where we mechanically spread the canopy with this low-tech device combined to a smartphone in order to be able to record all above ground parts of the plants. And then, for example, in this example, we are using video intelligence to count and measure the size of each and every spike, which naturally gives a very good estimate of yield potential and also a very interpretable estimate of yield potential. So one of the challenges with the, for example, like hyperspectral methods, which do provide powerful information, but the challenge with them may be that interpreting what, for example, near-infrared spectrum means for agricultural decision-making may at times be very challenging. So with this approach, what we can use these video intelligence estimates is to get very accurate yield estimates. So the correlation from the plain spike count, spike size estimates. Well, you probably can't see this. I'll enlarge it a bit. The correlation between this simple spike counts, spike size estimates with harvested yield is between 0.75 to 0.85. And there's no layer of machine learning at this stage yet, and this data is collected 1 month before harvest. And what we aim to do in the future, or what we're actually doing now, is that we are combining it with satellite data maps from which we can estimate growth zones in field parcels, and providing the farmer with a very low-tech retrofit with which they can sample videos from these growth zones, after which we can provide the yield potential map to the farmer who can use it, for example, for fertilizer optimization. So we're working in several research projects here. So for supplemental fertilization after flowering, where the when yield potential is high, providing wheat with a supplemental fertilizer in the finished growing conditions for a 50-hectare farm can increase profit by even up to 10,000, whereas in low yield potential conditions, adding supplemental fertilizer will only increase costs by a fact, well, 2,500 euros. So what we want to do is provide this extremely low-tech solution with which farms can get accurate information for the basis of farm decision making to be applied first in fertilizer application, but of course there are also other applications for this. Maybe at this stage, I'm sorry, I need to leave very soon. But the topic ties to what is coming later. So if anyone has any questions, maybe the best use for this time would be that I would answer those if anyone has any questions.
Yeah. So again, promoting to all of you, check the chat here in Zoom. Click the link that Linda shared and go to Padlet to write down your questions, or feel free to just open your mic, raise your hand, and ask your questions.
While waiting for the questions, maybe I could show something that might be interesting to people when thinking about AI, like something on the technology side.
Yeah,
so one more demonstration. So Basically, in order to train video intelligence to, for example, identify the spikes, basically some human would first have to go through thousands of images like this to annotate the spikes, which is the main limitation for using AI, getting the annotated data. To solve this problem, we use an approach called synthetic data, where we develop procedural 3D models of the plants, which we can then use to create tons of annotated data for training our AI. This is helpful for certain applications, and this is also one of the reasons why we believe that we can scale also to other crop species rather efficiently. We have been, for example, working with fava bean in addition to these obvious cereals applications. That's it from my part. So now looking forward to answer the questions.
Yeah, so we're still waiting for some questions, but I have my own right now. Farmers are very practical people, and I love that about them. So that's why I'm asking. You mentioned already some benefits, some very practical good things that this like yield systems helps you with. Like, could you just list out like very concretely, like why should farmers contact you and what would be the benefits they would get?
Well, there are two important things what we are focused at the moment. The first one is supplemental fertilizer optimization. So after flowering, the farmer needs to decide whether to add supplemental fertilizer or not. If yield potential is high, they definitely should do it. They can get even plus 22% of revenues, meaning 10,000 euros of profit for a 50 hectare Nordic farm. Whereas if yield potential is low, adding supplemental fertilizer will only increase their costs already at in a bad year. This is one, getting kind of actionable information for fertilizer optimization. Then the second one, which we are still working on, is selective harvesting. So by having a better map of the production in a field parcel, the farmer would have the possibility to harvest separately high quality areas, which can be sold as bread wheat, versus the low quality areas, which may be, for example, used for animal feed. And this is another example where we want to help farms be more profitable. And maybe to give the kind of our main religion has always been cost efficiency. So one can use a Yara N sensor to get a very good fertilizer map. And however, the cost of a Yara N sensor, to my knowledge, is at the moment approximately 20,000 euros. So it's very hard to justify that cost on a small farm. Whereas the retrofit, we will have to charge 1,000 euros to set up the customer relationship, but basically it's 1,000 euros plus 3 euros per hectare. So you get essentially the same information, but the price point is 1/10 of that of competing solutions. So simple cost efficiency. That's what we want to do.
Yeah, and it's the thing that we're looking for, right? Lowering the cost also helps us raise the income, right?
Yes, exactly. And then maybe the final we are not actually the speaker Jana today. Later she will be talking about this topic, but the idea is that the farmer actually owns the data. So the data that is produced can also be sold for other uses later on. For example, for carbon balance estimation. There are several, maybe some satellite prediction companies would want to buy data so that they can provide better. So the data is not like a single use thing. And as we record high resolution videos, the pixel is less than 0.25 millimeters. The same data could even be used for disease symptom detection. So what this technology will do, it will create a digital archive of data points, and that data can be used to create further revenue streams on a secondary market for various vendors.
But how will you make this system accessible to farmers?
Very good question. So basically, we provide the farmer with a retrofit kit. We do not take the responsibility of providing a product, because there are hundreds or thousands of different, like the existing base of farm machinery is so wide. And the second reason is that farmers like to build things. So we provide a minimal kit that the farmer can then attach to their existing farm machinery. And after that, with our app, the farmer simply sends us videos, which we process, combine them with the satellite map to provide them with a yield potential map. So this is one of the things where we've tried to be as efficient as possible. We see this as our kind of scalability strategy, that that we kind of build on farmers, or those farmers who are anyway our likely customers. They like to build things, so we let them build things, and we just focus on processing the videos into actionable data.
Yeah. How much more time do you have with us, Jussi? Do you get questions?
3 minutes. so
Awesome. So we actually have a few more questions. Yield system, is this a cloud-based solution, or how is this solved?
Yes, it's a cloud-based solution. Yes. So we have an app, and then that app is used to push the data into our cloud service, and then we process the data into estimates.
And do you work with vegetables as a crop as well, or you focus on...
We have worked with, we are doing some customer projects related to vegetables breeding. I can't talk about them, but yes, we are. And due to this approach of using synthetic data, our technology is very scalable to other crop species as well. So yes, vegetables, and well, yeah, that's, and maybe one thing to mention is that where our team has some more background on is building these simple low-tech devices that improve visibility on data. And actually this technique for canopy spreading, we patented it in most production areas. So building this, when it comes to vegetables, many of those also the machine vision would greatly benefit from better visibility to actual yield components, or whichever the trait being estimated. And that's what we do. We develop those solutions with which we can get the visibility. So very, very happy to work with vegetables producers, if there are any here.
I see. Awesome. Thank you, Jussi. Just any of my colleagues or participants, one last question before Jussi has to run. We have one question in the chat. Retrofit system. Yes, do you see it in the chat as well, Jussi?
Yes, I do.
What would be the price, for example, a 24-meter sprayer, your retrofit system you mentioned?
The way our current estimate is that if there's a 24-meter sprayer, the cost would be one smartphone plus the setup cost, which is like setting up the customer relationship, which is 1,000 euros. So the components, so the idea is that we would not be sampling the entire 24-meter width, but instead just choosing one place where the farmer sets up one smartphone to spread the canopy. And then those estimates that we get from that one point can be used to provide an interpretation for the satellite map of the larger area. So if the farmer is satisfied with getting 1 point from the width of the sprayer, then it's the same. 1,000 euros. 1,000 euros is approximately the cost for setting up this system.
Okay, awesome. Jussi, again, thank you. And we're super happy that you made it. And I hope you have time to run to your next meeting.
Thank you very much. I will. And I wrote my email address there on the chat. So in case anyone wants to talk more, I'm here.